Okay, in this video we are looking at the Module 7 reality check for Math 990, and we're looking at kinetic energy. It's an application of square roots. So in this one we're going to be looking at this equation, okay? This V equals square root of 2k over m, where v is the velocity in meters per second, m is the mass in kilograms, and k is the kinetic energy measured in joules. Okay, so we kind of read through, I'm going to let you read through this part, talking about what kinetic energy is, some examples of kinetic energy, and then here it goes into lagoon. Have you ever been brave enough to ride the cannibal ride? You look at the formula and you're going to determine the kinetic energy from some different people that wrote it. Okay, so this is kind of background information, and it is important to read through it just to make sure you understand kind of the background and what this problem is asking. So I do highly recommend that you read through this. So the velocity is 110 kilometers per hour, but this was converted into meters per second for you already. So it's 30.6 meters per second, which is the maximum velocity on the cannibal ride. So this is the value we will use for V in the formula. Now mass, to determine mass, we need to convert the weight in pounds of each person into kilograms. So we'll use this conversion factor, 1 kilogram equals 2.2 pounds. This hint, make sure you read this hint because that will help you to kind of check if you're doing it right. Okay, once you know both V, the velocity, and M, which is the weight in kilograms, you can find the maximum amount of kinetic energy a person would have if they rode the cannibal ride. Okay, so let's just look at this first one together. So let's get this window in the right spot. There we go. So we have Isaiah weighs 50 pounds. Well, first thing we need to do is we need to find his mass, or basically his weight in kilograms. So we know, we can say, okay, 50 pounds. Well, we know, let's make a fraction, we know that 2.2 pounds is equal to 1 kilogram. Now I set it up like this because when it's set up this way, the pounds will cancel each other out. They can cross cancel. And that's exactly what we want to happen. We want the pounds to cancel, so we're just left with kilograms. So basically then we'll just do 50 divided by 2.2 and we'll get 22.73. So 22.73 kilograms. Now if you remember the hint, if you read through it, it says people usually like their weight better in kilograms, meaning it's a little bit less. And so in this case, we're going to be right on. Be concerning if it was higher. So we have 22.73 kilograms is the mass. Now next we need to find the maximum kinetic energy. And so what we're going to do is we're going to plug these two numbers into this formula and solve. So we'll plug 30.6 in for V. We don't know K, that's what we're trying to figure out, and the mass is 22.73. So here we want to solve for K. Well, how do we solve for K? Looking at this, first of all, the problem is it's in a square root. And so we're going to want to square both sides, because when you square a square root, it cancels out. So the square root and the squared cancel each other out, and I'll just be left with, with 2k over 22.73 equals 30.6 squared, which is 936.36. I'm going to write it on the other side to give myself a little more space. Okay, so that's what 30.6 squared equals. Now I still need to solve for k. So whenever you have a fraction in front is kind of your coefficient, you can always multiply by the reciprocal. So I'm going to do that. Multiply by 22.73 over 2, because then those will both cancel out. So those cancel, the 2's cancel, but I also have to do it to this other side. So 22.73 over 2 we want to put that 936.36 over 1, and then we'll multiply. So 936.36 times 22.73 divided by 2 is going to be 10,000, oops, 641.7314, so I'll just put 0.73. So that's K, or our kinetic energy for that one. Okay, so basically you're just substituting in for the velocity and the mass and then solving for K. All right, so that hopefully will get you started. Reach out if you're still feeling confused, and good luck.